Good evening, everyone. This is the Q&A session 12 from the playlist of Electrostatic, Potential and Capacitance. The topic is combination of capacitors, and for this session I have taken this question which is written on this board. So the question here is, several capacitors of 8 microfarad and 250 volt rating are to be connected to get an arrangement of 16 microfarad and 1000 volt rating. So we have to basically get an arrangement of capacitors which should have the equivalent capacitance of 16 microfarad and the this voltage rating of 1000 volts. So here we have to find the minimum number of capacitors in parallel and series, a combination, to get this desired arrangement of 16 microfarad and 1000 volt rating. So let us consider that there are m rows of capacitors connected in parallel, first thing. Second point, let us consider that there are n capacitors in each row. So this is the first important point, and this is the second point, that I am considering that there are m rows of capacitors which are connected in parallel to each other, and there are n capacitors in each row. So we can draw this statement like this. Let us say this is one row which consists of n capacitors, and now in what will be there are m rows. Like this. So in this way there are m rows of capacitors which are connected in parallel, and each row has got n capacitors. So let us say this is the first row, so it will be having n capacitors. The second row will also have n capacitors, third row will also have n capacitors, and so on. So here in the question we have to find an arrangement of capacitors so that the equivalent capacitance is 1000 microfarad and the voltage rating is 1000 volts. So here we have the capacitors. Each capacitor has a capacity of 8 microfarad. Each capacitor has got a capacity of 8 microfarad and this voltage rating of 250 volt. Now if I want to get an arrangement which should have this voltage rating of 1000 volt, it means that the voltage across each row has to be 1000. Now since there are n capacitors here, and each capacitor has a rating of 250 volt, and since we require an arrangement which should have the voltage rating of 1000, so the value of the n, that is the number of capacitor in each row, n, this will be equal to what? 1000 divided by 250, because 250 is the rating of each capacitor. So this is equal to n is equal to 4. So first thing is that we have found the value of n, that is the number of capacitor in each row, will be equal to 4. This is the first thing. So here I will be writing the value of n, which is equal to 4. Now we know that in the parallel combination, the equivalent capacitance is equal to C1 plus C2 plus C3 plus C, and so on, where C1, C2 and C3 are the capacitance of individual capacitor. So if they are connected in parallel, then the equivalent capacitance of that combination will be equal to C1 plus C2 plus C3 and so on. Second, if those capacitors are connected in series, then the equivalent, this is in parallel, and in series. In series, the equivalent capacitance will be equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 and so on. That is 1 upon C equivalent will be equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 and so on. So here, now we have found that in one row, the total number of the capacitor is equal to 4, n is equal to 4. So the equivalent capacitance of any one row will be equal to 1 by upon C equivalent. This is equal to 1 by 8, because this capacitance of each capacitor is 8 microfarad. So this will be equal to 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8. So C equivalent, this will be equal to 4 by 8 and this will be equal to 2 microfarad. So 2 microfarad is the equivalent capacitance of the capacitors which are connected in one row. So this is the equivalent capacitance of one row of capacitor. So I will just write this, that is C equivalent and in series. C equivalent of any one row of capacitors. This is equal to 2 microfarad. Now there are m rows of capacitors which are connected in parallel, and in the parallel combination the C equivalent, that is C equivalent, is equal to C1 plus C2 plus C3 plus and so on, where C1, C2 and C3 are the capacitance of the individual capacitor. So here the arrangement should have the capacitance of 16 microfarad. So here C equivalent will be equal to 16 microfarad, and here we have got, and there are m rows, and each row has got a capacitance of 2 microfarad, and since they are connected in parallel, so 2 microfarad into m, because in the parallel combination the capacitance of the equivalent capacitance of the arrangement will be equal to the sum of the capacitance of the individual row. So here it will be equal to 16 microfarad, and this will be equal to 2 microfarad into, because there are m rows, so 2 microfarad plus 2 microfarad, 2 microfarad and so on. So this will be equal to 2 microfarad into m, or we can say that m will be equal to 16 microfarad divided by 2 microfarad, which is equal to 8. So the number of rows will be equal to 8, and each row will consist of, n was equal to 4, and each row will consist of 4 capacitors. So I think you must have understood the solution of this problem. So here I have taken this problem in order to just make you understand how we have to find the capacitance of a particular type of arrangement in which we are required to find the capacitance of a certain value and the voltage rating of a certain value. And in these type of questions, we are normally supposed to find the number of capacitors in the series and how many such rows will be connected in parallel. So I hope you have understood the solution of this question, and in the next question I will be taking up another topic, but the chapter will remain the same, that is capacitance. So till then, have a nice day. Bye.